Hello, everyone. Thank you for joining us today. We're very excited for you to all join us for today's webinar from both across Australia and across the world. I'm told we have well over 400 viewers from 14 countries, including Australia, which is wonderful. We would like to begin by paying our respects to the traditional custodians throughout Australia. We pay our respects to their elders, past, present, and emerging, and acknowledge the important role that Aboriginal and Torres Strait Island people continue to play within our community. I'm joining today from Jagera and Turrbal country, located in Brisbane, Queensland. For those who haven't met me, my name is Fiona McMillan Webster, and I am the science writer and content strategist at TERN, Australia's Ecosystem Observatory. So, a little bit of housekeeping. Please feel free to ask questions throughout the webcast using the Q&A function at the bottom of your screen, and we will answer them toward the end. If you have any technical issues, comment in the chat function and we'll try to resolve them as soon as we can. You can also use the chat to contact with other attendees. We are recording the webinar today so that we can share it with those who could not attend the webinar live. And this is our acknowledgement of country. So again, thank you for joining us today here. I want to go ahead and explain TERN for those of you who are not already familiar. We are a national research infrastructure project funded by the Australian government. We make all the observations and data collections that tell us about what's changing in the environment. We also collect physical samples and develop a range of tools and apps. Our goal is to help researchers studying both land and coastal ecosystems to gain a deeper understanding of what is happening, including both the magnitude and direction of change. When we say infrastructure, we mean our people and our instruments and the data. They're all covered under the definition of infrastructure. So today's webinar is Australia's Environmental Data Mosaic from Complexity to National Advantage. Let me give you a little bit of context first. Major national decisions now depend on rapid, trusted environmental intelligence. Organizations need data that is findable, interoperable, and ready for use at scale. The good news is that Australia's environmental evidence is expanding. Satellites, sensors, ranger programs, defense monitoring, and research infrastructures are generated unprecedented data. But fragmentation of that data means critical insights remain locked in silos. Without connected environmental data ecosystem, we risk slower responses, weaker accountability, and missed opportunities to build sovereign capability in environmental intelligence. Today we ask, how do we turn a fragmented environmental data landscape into a connected, resilient, national scale capability that serves reporting, operations, and long-term stewardship? It's my great pleasure to introduce our speakers today. Our first speaker is Alice McLaughlin, who joins us from the Commonwealth Department of Climate Change, Energy, and the Environment and Water. She is currently an assistant director in the State of the Environment Science and Data Management section within Environment Information Australia. She's going to speak to us about what's involved in tracking the state and long-term trends of the environment at a national level, particularly regarding the needs of the state environment reporting. Our next speaker will be Kerry Levitt, who is a solution architect for the Planet Research Data Commons at the Australian Research Data Commons, ARDC, where she's the boundary spanner between research users and the builders of digital research infrastructure to create platforms that transform environmental research and national decision making. He's going to talk about what's involved in bringing together and integrating different sources of environmental data. Our third speaker is Bradley Evans, who is a professor in Earth observation and remote sensing at the University of New England, where he's also chief investigator at the Earth Observation Lab. He's going to discuss how different organizations and users across Australia share and make use of environmental data and what lessons we can glean from that. So I'm going to hand over to Alice now. I'm going to turn off my camera and my screen. And Alice, if you could turn on your camera and share your screen, you can take it away. Thank you.
Oh, yeah. Try again. Share screen. Awesome. Okay, just a sound check. Can you hear me? And can you see my screen? That's the big green screen, Australian Government Environment Reporting.
Yes, that's great. Thank you.
Thank you. Okay, so I'll just start with a welcome to country. I acknowledge the traditional owners of the country throughout Australia. I'm joining you today from Jirrabal country up in far north Queensland. I pay my respects to their elders past, present and future. So today I'm going to have a conversation with you about environmental data mosaics, Australian government environmental reporting from the perspective of national state of the environment reporting. Slide. Okay, so just to start, I'm just going to define the state or status and trend concepts that are the theme of my conversation with you today. So the state or status is the most recent point in time capture, such as the present state for state of the environment reporting. Trend moving forward, and for SOE 26, State of the Environment Reporting 26, the trend will be the long-term trend as far back as data permits for that environmental data set. So there's a need for state and trend tracking. Of course, it's not limited to state of the environment reporting. All of these spaces are making do with what data and measure exists presently, but just imagine how much better things would be if there were to be more and better repeatable long-term state and trend measures. So I've got listed some examples: state of SOE reporting, environmental economic accounts. The EPBC Act, wouldn't it be good to accurately track cumulative impacts? National data sets also would be valuable that are readily available to use for assessments. The nature repair market is wanting to track benefits of projects at the regional to national scale beyond the single project level. State and territory state of the environment reporting would benefit from national data sets that they could just use where appropriate, rather than them individually needing to recreate separate data sets that they need for SOE reporting. Environmental and non-government organisations, well, they benefit from knowing where is on-ground action most needed and beneficial, that national state of the environment, state and trend reporting would benefit this causeful. Businesses, how could they avoid and where could they avoid impacts, and what projects would be good to support or do? And then researchers and on-ground practitioners. National data sets would be useful for research and applying to inform on-ground projects. Sorry, a bit nervous. I don't get to talk to big crowds very often. There we go. So I'll just narrow my conversation topic to fauna data, and also not limited to threatened species. This is a space I know quite well and am passionate about. So for these listed species groups, wouldn't it be great to have national community health tracking for these? So for each of these species groups, also different methods are needed for accurate presence, absence, detection, monitoring. So there are lots of different types of monitoring data sets and different accuracies to be aware of also. So for example, expert versus public ID. Some data sets wouldn't be accurate for absences, which is really important to track, or would miss detecting species with certain traits, such as critters that are nocturnal, cryptic, tiny, shy, flying fast, for example. And some data needs significant classification work, such as acoustics and chromotrap data. With frogs, for example, many species are hard or impossible to accurately identify visually, so you really need acoustic or sound identification. Calling typically happens at night. They're often small and hard to see. Some species are only out and about on wild, stormy nights. Human listening is presently needed to identify all species, but recognises, I believe, are being developed. Frog ID is doing a great job of recording national frog species occurrences, but they only started up in 2017. So what about the long-term trend data? Microbats are another example. They're tiny, they fly fast, they're out about and at night, so they're really hard to spot, super hard to visually ID. Acoustic ID is probably the easiest and most affordable option. Recognizers, I believe, have been developed for some species, but many need a bat expert person to identify. Nocturnal birds are a great example. They're typically not picked up in the BirdLife 2 hectare 20-minute surveys. They're cryptic, shy, only out and about at night typically. What about acoustics for these? And finally, I've got lizards and insects. Many lizard species live in very remote areas. They don't typically make sound. They're often cryptic, small, shy, hard to spot. Trapping and wildlife cameras are common for detection and to identify, but they're really time and effort intensive and used for small-scale single-site projects. So what could be done for state and trend tracking, presence detection and monitoring at a roughly national scale for lizards? And then finally, an example of insects. They're critical food web species, plant pollinators, so many and diverse. There's many local endemic species. Even entomologists or insect specialists can't quickly identify many species, let alone the general public. So often you actually need an actual specimen to study and time taken to accurately identify. So what good enough, affordable monitoring methods could work to track some version of a state and trend for insects or some groups of insects? Just putting some thoughts out there. Okay, so context matters. The context matters a lot for presenting the state of environmental factor, such as the fauna community group health. So what was the state originally? When should this be for reporting? Would it be good to aim for pre-European perhaps? Before X, then Y, then maybe Z happened. Is today's state a good or bad thing? So if the present state improved since last reporting period, can we all relax and celebrate, or are things still die? So how far back do we need the trend data to go to know if this present state is good, bad, okay, for this to be meaningful for informing on-ground action need? So I've just drawn up graphs, some examples of timings. This isn't everything, of course, but some examples of timings of different impactful pressures for Australian ecosystems and native species. So now, if you're reporting on a fauna group, if you skip when a critical impactful thing or things happened or began its impacts on the time series, trend time series, the present state would probably not look that bad, perhaps. Probably you would want to include or consider when the big impacts happened and include at least that time period in a trend series for accurate state and trend representation for reporting somehow. So an example, I guess a good one, is frogs. Chytrid fungus, you look at 1993, started its impacts. If you say start trend tracking frogs from just, let's say, 2010, you're going to miss that big impact of chytrid fungus. And so perhaps the state and trend wouldn't look so bad, but you're missing when the big problems happened. Small to medium-sized mammals, cats and foxes were really, still are, impactful. Habitat loss and habitat structure changes also. I've kind of got the big land clearing periods in there too for certain parts of Australia. So if you start trend tracking for, say, 10 years ago, probably they're not going to look like they're going too bad, but you're missing when the big impacts happened. Example being also another example, island nesting or living birds. Feral rats have been a big problem for these. So if you start trend tracking after the arrival and impact of rats, then you're not going to capture when the big impacts happen, and maybe they would look like they're going okay state-wise. Native plants, I'll give that as a final example. Land clearing, phytophthora, myrtle rust, native pollinator losses. So depending on your plant species, if you miss capturing when these big things occurred that were impactful for them, they might not look like they're going too bad for trends either. So the context really matters when you're tracking state and trends to know how far back your time series you want to go. It's having slide issues. There and there we go. Okay, so there's a few gotchas. Let's talk about the environmental data gotchas. These are probably all very familiar to you. Should we just all give up now until these are fixed? Well, yeah, not me. Everyone's probably across the continuing challenges for environmental data and state and trend reporting needs. So are we going to magically resolve these in the short, medium, or even long term permanently though? How about we continue to figure out how to work around these gotchas instead, so they are not impassable blockers to meaningfully tracking the state and trend of the environment and native species. So first cab off the rank, national coverage. Most data is recorded near where people live. There's big gaps in remote areas. And so what are the options monitoring in remote areas? I've got a great example. This is Frog ID, all their records to date. And as you can see, clustered around where people live and big gaps in the remote areas where not many people live. Data perfection. We could all aim for gold standard, high accuracy, high quality, complete coverage, quantitative data sets. But yeah, achieving perfection is expensive. It's often impractical and realistically, is it really possible? We can't go back in time for historic trend data. I don't have a time machine, but do you? Yes. So what about historic paper records? What about First Nations knowledge? So to achieve valuable, much needed long-term trend data sets, we're going to need to apply some creativity. The final big gotcha I'm going to cover is funding challenges that we all experience. Yes, me too, multiple jobs. Is the funding sufficient for all identified monitoring state and trend tracking needs? Is the funding long-term? Is it timely? Is it responsive? Is it dependable long-term? Yeah, really reality check. So really, we're going to need to apply some creativity. And I've just included on the slide, these are some fabulous examples where some of these types of challenges have been worked around to achieve significant benefit for the cause of environmental data. Behind each of these organisations or entities are many really passionate, hardworking, can-do people. So thank you so much for your efforts. Right, let's talk about data that we need for reporting. The source data that we need for state and trend measures reporting. So where does this data come from? Who has it? Is it able to be shared, accessed, discovered, used to nationally and publicly share how Australia's many ecosystems, broader environment, native species and pressures are tracking, but across time? Also, what abilities, gadgets, classifiers, or partnerships such as wild ops, open ecoacoustics, are newly emerging that could significantly contribute to this space? How can we support as yet unshared datasets to contribute to tracking the environment? What do these people or organisations need to be supported or enabled to participate? What camera trap survey data images do you have on a dusty hard drive somewhere? Yep, me too. So also, if say you install an acoustic recorder, could you perhaps add the ability to record microbats too? Just thinking if future recognizers could be run on historic datasets, but so long as that data exists to be classified. Let's talk about expert analysis that we need for reporting. So for the environmental reporting space, we generally can't internally interqueue, for example, expertly analyze and convert raw monitoring data to state and trends or indicators. This is just way out of our expertise. Also, often we don't know what could be done and where all the different data sets exist, other than the obvious places such as BirdLife, Atlas of Living Australia, and TERN. I'm talking about fauna data examples here. Now also just remember that funding conundrum. Developing assessment-ready datasets is quite a process, we know. It takes time, often years, huge amounts of effort, expert skills, relationships with data holders and collectors. Developing credible, good enough, accurate state and trend measured methodologies, and also, for example, community classification typologies takes significant time, effort, persistence, and creativity. So these are long-term endeavours beyond short reporting need identification and typical funding cycles. So I've just included on the screen a fabulous example of the National Terrestrial Bird Health State Index and Community Classification Typology. This has taken this project team years to develop, champion and progressed by a small group of individuals. However, it's been contributed to by many expert individuals and organisations. Now, my final slide. Why should you care? What's in it for you? Why should you want to share your data sets or contribute your time and expertise to progress a quality pool of national, state, and trend measures? Would you like the things that you love and care deeply about to be meaningfully publicly tracked to inspire better environmental outcomes? The bonus is also value-added state and trend measures and data sets and collated data that in turn you could use for your professional, business, research, advocacy, personal or other needs. National coverage also includes the ability to explore at the regional or local level using the derived data, depending on what the source data was used to achieve that measure. So it's not just only homogenized to the national level is what we're aiming for. So I'm just going to close with, let's work together on opportunities, possibilities, and solutions in this complex but really important space. I'd love to hear from you. questions, and that's a later thing. And next, I'm going to be handing over to Kerry Levitt, who is working with the ARDC.
Thanks, Alice. I'll just share my screen and make sure I've got the right one. Okay, hopefully you can all see my screen and hear me okay. So, hi everyone, I'm Kerry Levitt from the Australian Research Data Commons, or ARDC. I'm going to show you a few examples solving some of the challenges with finding and using data for environmental trend monitoring, management, and reporting that Alice has just talked about. So, like TERN, the ARDC is a national research infrastructure facility. While TERN collects the environmental data, we enable the digital data infrastructure, and we work across all research domains. We strive to accelerate research through platforms, standards, and expertise in analysing and managing high-quality data assets. So the Planet Research Data Commons is ARDC's focus on earth and environmental sciences. I encourage you to scan the QR code here to see the platforms and services that we have that you can use and learn more about us. We work with our partners to build platforms and services, and those partners include fellow NCRIS facilities like TERN and Atlas of Living Australia, universities, and government departments. Now, I'll just give you a quick overview of what we do. We work on establishing trusted environmental data and information supply chains with industry, research, and government by setting up the governance and technical frameworks to enable efficient data sharing. We work with our partners who work with research communities in specific domains like TERN to support the use of data standards and metadata, and we support projects that create integrated, fair data sets and services. We work with our partners to develop and operate national infrastructure for modelling, analytics, and decision support, and for processing large amounts of sensor data. We also have a program with our fellow Earth and Environmental Science research infrastructures that's building our collective capability around the governance of Indigenous data and implementing the CARE principles. And finally, our skills program upskills researchers to use these platforms and services. So we defined these programs through national consultations that we undertook in 2023. And we heard in these consultations that data was really hard to find for researchers and government users. Another thing we heard was that managers of research programs also found it hard to track the data and outputs from their programs. So I'm going to give you examples of making data easily discoverable from these two different perspectives, from a researcher and a program administrator or funder. So first we'll take a program administrator's viewpoint, and we'll look at the National Environmental Science Program, or NESP. NESP is a nearly $150 million research program administered by the Australian Government's Department of Climate Change, Energy, the Environment and Water. The program's divided into 4 thematic hubs with more than 37 unique partners and over 200 research projects between them. The administrators of NESP wanted to report back to government on its return on investment, including the program's impact. So, have the research outputs been used in policy or management decisions or further research? But they didn't have any way of tracking these outputs because there's no central repository. Data and other research outputs like software and models are published by the researchers by their own institutions. So the ARDC worked with each of the 4 NESP hubs to bring their data together in our Domain Data Portals program. We helped them mint persistent identifiers called the Research Activity ID, or RAID, for the NESP program overall, for each of the 4 hubs and each of the hub's 200 plus projects. We used Research Data Australia to create these hub data portals. Research Data Australia is an online portal for finding research data and software and its associated projects and researchers. It aggregates metadata records from over 102 contributors, and it provides access to data that is stored by the source organisation. Now, remember I said NESP researchers publish their data via their institutions. So we worked with these 37 partner institutions to enhance or establish their metadata feeds to Research Data Australia, standardise their metadata, and include the Research Activity ID, or RAID, in the metadata record to identify the NESP project outputs as belonging to the NESP hubs. These were all brought together in a data portal for each of the NESP hubs within Research Data Australia. In this case, we've created a NESP Marine and Coastal Hub portal that enables
the administrators to see all of the hub's outputs in one place and to see metrics for these. Like how many times has the data been accessed through the portal and where is the data published from? The program also upskilled researchers in how to publish their data, including what metadata standards to use to make the data reusable. So these data portals can be configured to discover research outputs from a single program or a research group or an organization or even a whole domain, depending on the use case. So this is the Marine and Coastal Hub's data portal interface. The NESP administrators can now use Research Data Australia to provide a human readable view of the funded outputs, regardless of where they're hosted. They also use the Research Data Australia API for more intensive analytics to answer questions about the program, such as which data holders are we particularly reliant on, especially when those data holders are not directly engaged by the department. This has helped them understand the networks that support NESP and will inform the design of the next phase. The researchers receive training on data management and their processes are now more fair. And this can be adopted by any Australian research community who wants a focused view of their research outputs. So now let's move on to a researcher's perspective. These domain data portals are great for bringing data collections together in one place, but they don't make the data more interoperable, which is what really accelerates research and allows us to address the big environmental challenges. So Austrates harmonizes data on Australian plant traits and makes it analysis ready. It's a project led by UNSW and it's a collaboration between ARDC, TERN and others. Austrates synthesizes more than 300 data sources on over 500 plant traits across more than 34,000 Australian plant species. The data is collated from published literature, floras, and data that researchers contribute directly. The dataset is published as a data paper in Scientific Data, and all researchers who contribute data are listed as co-authors. The Austrates team has developed software tools to harmonise the data and to apply standard vocabularies, which they have also published. Besides the data publication Scientific Data, the data is published on Zenodo, and it's also available as an R package, and can now be interrogated via a new user interface on their website. They've also published the software packages that enable them to build the database, so other research groups can create their own trait databases, including one for invertebrates. So this integrated dataset is enabling faster and novel research, including prioritising management actions and planning following the 2019-2020 megafires here in Australia. And the Austrates data paper has been cited over 230 times. So an example of a platform providing an end-to-end workflow to create an integrated environmental dataset is the Wildlife Observatory of Australia, which was launched just this week. WildObs, as it's known, is being developed and operated by QCIF in partnership with ARDC, TERN, Atlas of Living Australia and others. It's a national platform for processing, managing and sharing wildlife camera data. Wildlife cameras, or camera traps, enable long-term monitoring of fauna and is particularly useful in remote areas. And WildObs accelerates the processing of large amounts of images from those cameras to get actionable insights. WildObs allows researchers and land managers to upload their camera trap data camera trap photos to the image platform and use the AI models to identify the species in the images. The species detections are then stored in the WildObs database in a standardized format and with standardized metadata about the camera deployments. The platform also includes a repository of tagged images which can be used to train and refine AI models for species detections. The species occurrences are then sent to the Atlas of Living Australia, where they're integrated with occurrence data from many sources. And very soon, TERN will be hosting presence-absence data supporting long-term monitoring. Open Ecoacoustics is very similar to WildObs, but for acoustic data rather than images. And again, acoustics enables long-term monitoring, works fabulously in remote locations and at a national scale. So this program led by QUT and James Cook University in partnership with TERN, ARDC and ALA is a meta platform that researchers, land managers and citizen scientists can upload their acoustic recordings to with tools for metadata standardization and file management. It has AI tools called recognizers that can identify species, and there are repositories where you can search for data. Its tools are used to great effect by research programs working with citizen scientists to identify calls from particular species, including this powerful owl. So this data helps understand environmental changes through big data, allowing for informed environmental management decisions. And that is it from me. There's that QR code again if you want to scan that to get more information on the Planet Research Data Commons. And now I'll hand over to Bradley.
Thanks, Carrie. I have thoroughly enjoyed your presentation. So I'm Professor Bradley Evans from the University of New England, and I am the last speaker for today, and I am going to be talking about this whole topic somewhat generally from my experience with TERN over the years, also my experience at Defence, and generally working with data on a daily basis. First of all, I'd just like to throw out an acknowledgement of country to my local countrymen, the Anyone. I'm coming to you from Black Mountain in New England, New South Wales, not this Black Mountain in Canberra, not to get confused. I'd like to pay my respects, past, present, and future, to the Anyone, also known as the Bear People. So the good news, everyone, is that productivity is up. I was part, when I was intern, I was part of the National Environmental Data Store, we called it at the time, on the NCI, and it's growing at 15 terabytes a day. Just to put that into some perspective, if I was to fly a NASA aircraft around the country, that would be the data that we would create every hour flying that around, and that's a massive amount of data consolidated on the NCI. We're over 150 petabytes at the moment of that, and spread around the country and on a different ARDC services and other services. TERN themselves have over 3,000 data collections. And to put that into perspective, one of the things I did in TERN was create a climate data set for Australia that's 1 kilometer resolution every day, and all the variables that you'd expect to have from data. And so that's just one collection, and there's thousands and thousands of data files. And a lot of our collections are like that. And you've seen some different numbers today talking about the various amounts of collections that we have, and it's a lot of data, and you need to learn to have skills. This data has also helped us understand that we are also in a state of decline, with 19 or so ecosystems, perhaps more today or perhaps less. We'll find out soon enough, are in decline or near collapse. And of course, there's a lot of an increasing number of threatened species around the country. This is all information that we can have high confidence about from all these activities that you've just heard about before me today. Another thing that's on the horizon I'd like to bring to your attention is qubits. These are 8 qubits, and the title of my presentation slide. I just wanted to put that out there for all you data nerds online today, because we will be getting there. And quantum computing promises for us environmental scientists and the like to improve the way we optimize our data, our analysis of our data, to enhance the analysis of the data. And so I look forward to that opportunity as it comes, because working with our data is a culture. There's the creation of it, the desire to create it, the sharing, how you do that sharing. And of course, that's all linked to the individual. And it could be hard work in the field. It could be hard yakka behind the computer like me, mostly. And it could also be teaching it. And obviously that's part of what I do as a professor. And a lot of the culture is driven by where that person themselves was educated. Until we had NCRIS, until we had facilities like TERN and ARDC working with the community on large, and running little data seminars for people, creating tools, creating R packages for Tool A to share it. But still, with all of that, we still have around only 16% of researchers sharing their data. That was over a decade ago. And today we think that's about somewhere more than 16%, but still around the 30% mark. That needs to change. So I hope our talks today have inspired you to reflect on your behavior and your culture, and have a think about how you can contribute back And part of the problem is that around half of us find it hard to organize data for reuse. And that's part of the process of submitting it, is being able to have the time and the energy to form that data in a way that you can easily share. A lot of people are still unsure about licensing. This is actually something that I go through quite often with all the projects that I get involved with people, explaining licensing to people. So it's not that hard. A little bit of research. Of course, we can standardize that, and we do try to do that. And then, of course, you do get lost a bit in the haze of all the places to put your data into. And we learned about a few today, and I think those are really fantastic examples. When we started all of this decades ago, part of the problem was Australian researchers wanted and are expected to also develop and maintain international reputation, and some of the rest of the world was ahead of us in certain areas. What we've done is we've synced these together, so you can put your data in an Australian repository and it gets recognized internationally. And I can certainly tell you the history lesson from when we started this is international people will find you and want to work with you as an Australian on their project. And there's many examples of that, including my list of publications. So the organizational units that create and facilitate this sharing are the groups that you've heard about today: ARDC, TERN, and of course they are focused in the environmental sciences and ecology, and obviously they communicate mostly with people in your discipline. But I would also encourage you, and as part of my observations and themes in preparing this presentation for you today, to think a little bit outside of that, to think more broadly, to think about the very wide audience that groups like ARDC apply to as well, because we need to get that connection and that sharing together to make a better job of this. So essentially, there are about 3 cultural layers that are involved in the whole realm of data sharing. There's the individual, that's you, and rightly so. You're probably scared of having your data scooped, and you don't really want to put all the effort in to prepare the data for sharing. But trust me, it's worth the effort, and also there's lots of help available to you today. And in the last decade or two, we've increased, I guess, computer literacy and the learning of programming languages like R and Python, and of course AI can really help you with that as well today, to shape and format and test, statistically analyze the data that you're preparing to share, to discuss things like licensing with you, and to help you to get that in. TERN has a number of tools as well. They create document object identifiers, they have controlled vocabularies, and they have worked and chipped away at various sorts of compliances. And of course, there will be a culture in your specific discipline, whether that's ecology, environmental science, ecosystem science, natural resource management, zoology, whatever it is in your discipline. There will be different epistemologies. We understand that. The people at the NCRIS facilities understand that. And they themselves spend a lot of their day-to-day understanding what standards are out there for this, understanding what accreditations are at this, and generally speaking, what the norms are. Of course, TERN's done this on a multitudes of levels with their data collection. We heard from others today about the standardization of data collection. That's really important, so we can compare apples to apples, and we can aggregate these data up from the individual through the disciplines to the institutions that actually want to do great things with them, like our State of the Environment report, for example. And of course, one of the big problems that we've had, and we've done a lot of work to solve over the years, is the institutional problems. Back in the day, there was no career credit for data curation. There's now data publications are a thing. I've really been pushing for decades with no success on having code publications. So you get your R packages or the code that you share also recognized. I'd like to see that still. But apart from having not credit to your career for that, we also need to have incentives for papers that talk just about data or data publications. for our researchers and academics. And of course, they need to think about things like security. For example, if the data is of national interest and something that defence are interested in, then perhaps the data, no matter how important it is, might need to have some security put on it. And that's certainly something that happens in our defence forces on a lot of their data. And of course, accreditations are really important. That's what helps make that link to your career. TERN on licensing in particular has always worked towards CC4, which can be prosecuted in Australian legal systems if need be. Of course, the document object identifiers and linking with other institutions like TERN around the world, which has been really successful. One of the problems that we face with all of this is, of course, that there's this fragmented funding and fragmented infrastructure. Now, we had to do that for reasons. The structural problem is environmental monitoring is split across the federal, state, territories, and local governments even. Defence themselves have 3 million hectares of a state. Now, that's the size of Belgium. That's 12.5 times the size of the ACT, where the other Black Mountain is. And of course, the thing about this is that that's a lot of information, a lot of people, and there's no police force for environmental monitoring. There's nobody telling you have to do this. What we're doing with all of this is we're saying we've built this amazing system. Come and use it. Come and save yourself some time and come and share so that we can all benefit from it. And of course, some of the problems that flow from this fragmentation is we've ended up with the train gauge problem for environmental monitoring across all states, where we have different ways of designing what arguably is the same continental vegetation system. And of course, land clearing is increasing. We do police that. And there's different ways to do that in each state. So there's a challenge as well that sometimes draws some international mire to it as well. But generally speaking, despite all this effort, we can still do a lot more, and we should. So NCRIS has solved a lot of the problems for us. We've got multiple institutions, NCRIS facilities, capabilities that work on different aspects of the problem, deep diving into the problem and really getting to the bottom of many of the challenges. As we've matured over the years, of course, that has created some sort of siloing that we need to deal with, and we are. And you saw today excellent examples from ARDC, giving us a really strong case for why they've developed systems in conjunction with TERN, in conjunction with others, to address this. And of course, we've heard of the use case there, the state of the environment report. We need to get this together to fix some of these problems, and we're doing more. One example of how that works is the eco assets, and these examples that I'm giving you will continue to grow and develop over time as we move through systems. And I think this concept of systems and a systems engineering approach. There's a little shout out for my upcoming campaign with NASA Avarice. We're bringing that out to Australia, and what we are doing there with any mission, as the space agencies do, is think about the system boundary, bring all those people together that come into that boundary, think about how to standardize the connections between those people that are working on it, and listen to their ideas, what they're doing, to make sure when you integrate all of this together and you get to the end point and you verify and validate what you've done, that what you have done has met the target. And you can only really do that when you have everyone with a voice in the room and you listen to them. And this is good news because as we move towards this mosaic of infrastructure that connects the various fragmented pieces, we are going from complexity to creating a national advantage for ourselves. And we can do it. I think we've demonstrated today as well that we're all working on it and we're all thinking about it. We've got to move quickly. There's a real deadline on this, and we've got to make sure that as we do this, that we bring the good elements of the culture together and bring it forth. So that's all from me. Please feel free in question time to hit us with any questions and get in contact if you'd like to discuss data or Earth observation with me. Cheers. And I'll just hand back before I forget to Fiona. Fiona, are you there? Yes.
My apologies for that. My Zoom screen just shot off to a completely different screen.
I could have kept
Thank you.
talking. Yes.
Thank you everyone for such a wonderful talks today. It was absolutely fascinating, and I think really came together well. We could see how the different components work together. It's now time for the Q&A, and so I just want to encourage the audience to please ask questions. We've got a nice amount of time for questions today, and I'll go ahead and begin with the first one that has come in, which is for Alice. Our marine and terrestrial environmental data sets are collected, hosted, and used differently. This is all okay until we start talking about the coastal environment. Any suggestions for better integrating terrestrial and marine data sets to better understand status and trends along the coasts?
I was Look, while Alice is dealing with their connection issues, I have an answer. Well, a partial answer to that is in the latest round of NCRIS funding, the Coastal Research Infrastructure, or COAST RI, has received funding from the Department of Education to start up, and that is a collaboration between IMOS, TERN, ALA, OREN, uh, ARDC, and I have forgotten some others, sorry. But so that is actually looking at bringing, our IMOS, our marine research infrastructure, and TERN, our terrestrial, together, with all the other supporting infrastructures to address exactly that. So watch this space.
Just on that, actually, since you mentioned the marine and the IMOS, for the marine, the portal example that you gave, where they see the research outputs, is that data, is that coming from a publication specifically, or is that just more broadly any data that's come out of that particular funded project?
Yeah, it's any data that's come out of that funded project, but data, software, models. So they'll typically produce a report for that they're all the reports are available on the NESP Hub's websites, with presentations and things like that. But this is the actual raw data. Yeah. And it's published. So the Marine and Coastal Hub, most of it will be published through AODN, the Australian Ocean Data Network catalogue, and then Research Data Australia harvests that metadata.
Wonderful, thank you. I'm just checking with Alice to see if she's had any luck with her connection. If not, don't stress. We've still got plenty of time to get that up and going. So I've just had another question coming in saying, thanking everyone for the wonderful presentations. With all these great tools and increased data access, how do we distinguish between increased data availability versus real environmental change? And it's not for anyone in particular, so anyone can jump in on that.
That's really one for Alice. Unfortunately, she's Alice would be the expert on that one.
I think she's reconnecting. If she does
So
come back on, I'll repeat that. But yeah.
Yeah, I was going to say the obvious go-to would be standardization, and we've done a lot of work. Kerry, maybe you could elaborate on various ways of standardizing the different repositories that are around into single systems. I think that would be something you're doing in WildObs and Austrates and things like that. And so when you do that process, you are then able to look at it through time and distinguish whether that's real environmental change or not. So that'd be my answer, Sarah.
Yeah, I think that requires really good data science, really good statistical techniques is the important thing there. So there's data science and data synthesis centers, and yeah, that's really important there. But yes, if Alice comes back on, she'll have a good answer.
And another one's come through on citizen science data, which is interesting. So, any tips on how to get citizen science data integrated with government databases and reporting? It has the ability to fill many gaps. Is that something that you've had experience with on your end, Kerry or Bradley?
A little bit. I think using so the ALA has really great citizen science data apps, and then things like Wild Orbs and Ecoacoustics have the provision for anyone to upload data, and it's the verification process that that say the images will go through the AI species detections, and then there's a human verification of those. So the data is of a really good quality, that can be used for research or for government purposes. So I think it's about making sure that all of the data has appropriate verification and quality assurance. Yeah.
And a lot of people consider ALA data and publish it as citizen science data in their publications. That's a cultural thing that I've detected in the community. I find that a little bit unfair. That's a very broad brush. There's a lot more than just citizen science data in ALA, so it's sort of clumping other things together. But yeah, I think as we do improve our standardization and we integrate more statistical techniques that Kerry talked about, we're going to be able to do that with ease.
Um, Thank you. And this actually touches on a point that you had raised, Bradley. When you're talking about organizing data for reuse. And I imagine part of that comes from developing good data management habits. So I've got a question that's coming on. What advice you would give to students and early career researchers for developing those good data management habits, or contributing positively to the space in our own work? And the person who asked the question is particularly interested in where it relates to spatial data.
Yeah, and I just taught that this trimester. So it's it's an ongoing task, right? So you need to understand some concepts and some theory about how to manage data on the platform that you're on. And also I encourage students to get their hands dirty, to go and download some data from TERN or from ARDC or from ALA, and to look at the format that it comes in and to read into those standards and those structures and set up a framework for handling it and using it in your code. I work with Python a lot. I have made ARC packages over the years. I understand both, but there's a process as well for how you read those data back into your scientific analysis workflows. So I don't think there's any substitute for getting your hands dirty with it in the same way that we love going out in the field and getting our hands dirty identifying species and digging holes and all those things. Just take the same approach for the data.
It sounds like something that, yeah, the earlier guess those approaches are ingrained for the students, then the better. And also, once the project is then finished, it's much easier to then be able to share it. Another question that has come in is we're getting much better at collecting environmental data, but arguably still not as good at turning that data into shared understanding. How do you see the relationship between data commons and what I call longitudinal landscape intelligence, systems that help interpret how landscape function changes over time in response to climate variability, hydrological behavior, land use change, and production cycles? Is that where you see the next layer of value emerging?
Definitely. Alice, you're back. Did you want to take one?
Yeah, sorry.
Yes.
Can you hear me
Yeah.
now?
I
Yeah,
kind of feel like that one's
my computer decided to reboot. Um, I'll probably need to take that one on notice, and have a good think
okay.
about that question. So thanks.
No, that's fair enough. Look, Kerry, unless you got something to say, my answer on this one would be again, like we were talking about data management. It's something that you really got to start teaching early and building into that culture. And educators like me, we do that. We also in my field, we collaborate across our field to work on this strategy together for how to get and increase the skills of interpretation. And right across the increased facilities, we have data that's useful for understanding and quantifying that climate variability, the hydrological behavior, and that land use change, of course. The only other thing I've got to say to that one is although we do report at the highest levels on land use change, I tend to think of ecosystems as a continuum and don't like those hard borders. And I do think that if you do that and take that approach, that it's easier to understand that longitudinal change, because, an arbitrary boundary isn't, when you're trying to understand change, doesn't really help things.
Oh, thanks, Bradley. I'm just going to go back to that original question that Alice wasn't able to get to before. That's okay. Give you a chance to respond. Carrie gave us her response from her perspective, but to repeat the question, our marine and terrestrial environmental data sets are collected, hosted, and used differently. This is all okay till we start talking about the coastal environment. Any suggestions for better integrating terrestrial and marine data sets to better understand status and trends along coasts? And just jumping to the next question, we've just got a bit of time for a few more questions. Is what do you think, and this is for anyone, what do you think of some of the gold standard data sets available right now? We had some good examples presented today. I don't know if you can expand on that.
Can I jump in on that one, Fiona?
Yes.
As the director of TERN, we know that the Threatened Species Index has been noted by the Australian Bureau of Statistics and Treasury as a metric that matters, and it's now used operationally by the Australian government to provide their data on the status and state and trend of threatened species in Australia. And there is a webpage, tsx.org.au, for people that want to see what gold standard data in the environmental space looks like. Thanks.
Thanks, Farrell. Another question is, while having access to data is important from many perspectives, ensuring consistent data quality is essential. How do you ensure data quality is maintained? Happy for anyone to jump in.
Yeah, I think data quality is an interesting attribute because there's no one definition of what good quality data is. Is your data fit for purpose, for the purpose that you're using it for? So it's really important to have really good descriptive metadata that describes how your data was collected, what methods it was collected with. Put your data in a standard that others in your community use, so a community agreed data standard. Have descriptive metadata that describes how it's been processed. So there are also certain standards around describing quality, so you can have different processing levels for data. Bradley might be able to talk about that, especially with spatial data, but a lot of it is about describing it, so then the user can decide whether that data is fit for their purpose.
Yeah, I was going to
Thank
add,
you.
Kerry, just check it again and test that, that it is fit for purpose. There's no real escaping that one, right? So, yeah.
Yeah, and I think, and this is also in answer to the question about advice for students and early career researchers, is collecting your data. The way you collect your data is so important. So I know for terrestrial data, TERN has a whole range of standards for how to collect your data using in different methods. So the EMSA standards. In marine, there are large numbers of published standards for different collection methods. And if this is what your community uses, that's what you should use. And then that means that your data starts off being interoperable from point of collection with other people's data sets.
Wonderful. Thank you. And so we have a few more questions, but I'm afraid that we are out of time. With the speakers, we will definitely have a look at these questions and pass them along to the speakers, and hopefully might be able to get those answers out to you. Please join me in thanking the speakers for wonderful presentations today. It was really interesting, and I think we've gotten a lot out of it. Again, this has been recorded, so if you want to go back and review this, that will be available very soon on the TERN website. Join us for more webinars. We've got another few coming up. We've got one, the next one is on the 5th of August, and then following that, the 7th of October, and the topics will be released soon. Once again, it's been wonderful having all of you, Alice, Carrie, and Bradley. Thank you so much. And thank you to the audience, to everyone around the world who joined us today. Right. Thank you very much.
Thanks.
Thanks, Fiona. Bye.
Bye, everyone.
Bye.